Right. So now we'll continue Chapter 2, Section 2, the Algebra of Functions. When we say algebra of functions, we're simply stating that with functions, we can do what are called the binary operators. We can add them, we can subtract them, we can multiply them, and we can divide them. Binary operators. Reason they're binary because you have to have a number in front and behind it to mean anything. All right, so that's what we're looking at here. The algebra of functions is we're going to take two functions and add them, subtract them, multiply, and divide them. So let f of x equal 2x squared plus 3x minus, well, let's start off small. Let's start off small. 3x minus 2 and g of x, let's make it 4x. So the first one we're going to do is addition. We're going to do f of x plus g of x. This can also be written f plus g of x. We can look at it that way as well. So what this thing says is take the first function, 3x minus 2, plus the second. It's safe to put them in parentheses because if there's a coefficient or a sign coefficient, then it'll change the whole thing. So do I need the parenthesis? No, nothing's in front of it. Do I need parentheses in this one? No, there's no number. It's just a plus, so it's plus 4x. Now combine like terms. 3x plus 4x is 7x minus 2. Let's look at subtraction. F of x minus g of x. So we have, again, 3x minus 2 minus 4x. There's nothing in front of the first one, so I could drop the parentheses. Oop, that's 2. There's a negative out in front. Combine like terms. 3 minus 4. It's negative, but 4 is bigger. 4 minus 3 is 1. So the answer is negative x minus 2. Also, let's go ahead and look at, would it be any different if we did g of x plus f of x? So 4x plus 3x minus 2. There's nothing in front of that one. Nothing in front of that one. 4 plus 3 is 7. X minus 2. So it's the same. G of x minus f of x. 4x minus 3x minus 2. 4 of x is okay. This negative changes all the signs inside there. So it becomes a negative 3x. Negative and negative makes it a positive. 4 minus 3 is 1. It did change it. See, so that's why you have to be very careful because depending on where you position it, it can change your answer. Let's try multiplication. f of x times g of x. We will also check out g of x times f of x. So as you're multiplying polynomials, so f of x is 3x minus 2 times 4x. Distribute. 3 times 4 is 12. X times x is x squared. Positive times negative is negative. 4 times 2 is 8x. So g of x is that. 3x minus 2. 4 times 3 is 12. X times x is x squared. Positive times negative is negative. 4 times 2 is 8. So it stays the same. Right? And then the last one is division. F of x over g of x. We're also going to look at g of x over f of x. So it's 3x minus 2 over 4x. At the top and the bottom. That's one equation. You can't cancel indiscriminately. If you're going to cancel anything, it has to be this in the whole equation. All right, so this is as far as you can go. The only thing about it is x cannot equal 0 because you cannot have 0 on the bottom. So we set the denominator equal to 0, divide by 4, x equals 0. So x cannot equal 0. On this one, 3x minus 2 is positive 2, divided by 3, x equals 2/3. So x cannot equal 2/3 because if it equals 2/3, then the bottom is 0. The only thing different now is you now have a restriction on what you can use. All right, let's look at bigger ones now. That f of x equal x squared plus 5x plus 6. G of x is x plus 2. The addition. And we found out earlier that it doesn't matter which, the addition is commutative. So if we do f of x plus g of x, it's going to be the same thing as g of x plus f of x. So you don't have to do both of them. So the first one, f of x. F x squared plus 5x plus 6 plus x plus 2. So I need the first parentheses. There's nothing in front of it, so I could drop them. There's nothing in front of the second one except the plus, so I just drop the second one. Combine like terms. There's only one x squared. 5x plus x makes it a positive 6x. 6 plus 2 makes it 8. So there's your sum of two polynomials. Subtraction. We're going to look at both of them separately. F of x minus g of x. and g of x minus f of x. See how much it changes. X squared plus 5x plus 6 minus x plus 2. X plus 2 minus x squared plus 5x plus 6. All right, so let's get this. We don't need anything in the first one, so we drop the parentheses. The second one, since it has a negative, I got to distribute it inside there. So it just changes everybody's sign. So it becomes a negative x, makes it a negative 2. Only 1x squared, 5x minus x, since 5 is bigger, so it's 4x. 6 minus 2 is a positive 4. First parenthesis, I could drop the parenthesis. Since there's a negative in front of it, I got to change all the signs inside there. So that positive x squared becomes a negative x squared. Positive 5x becomes a negative 5x. Positive 6 makes it a negative 6. That just means change all the signs inside there. Combine like terms. There's a negative x squared. 1x minus 5. 5 is bigger. 5 minus 1 is 4x. 6, 2 minus 6, 6 is bigger. 6 minus 2 is 4. So this is just the negative of that one. Let's look at multiplication. So we have f times f of x times g of x and g of x times f of x. So f of x is x squared plus 5x plus 6, x plus 2. And this is going to be x plus 2 times x squared plus 5x plus 6. So what we have to do here is everything in the first parenthesis has to multiply to everything in the second. Distributivity, pretty much. So x squared times x is x cubed. Positive and positive is a positive. X squared times 2 is 2x squared. Positive times positive is a positive. 5x times x is 5x squared. Positive times positive is a positive. 5 times 2 is 10x. Positive times positive is positive. 6 times x is 6x. Positive, positive. 6 times 2 is 12. Combine like terms. So I have x cubed. 2 plus 5 is 7x squared. 10 plus 6 is 16x plus 12. Do the same thing here. So x times x is x cubed. Positive times positive is positive. X times 5 is 5x squared. Positive and positive. X times 6 is 6x. Positive and positive. 2 times x squared is 2x squared. Positive and positive. 2 times 5x is 10x. Positive times positive is positive. 2 times 6 is 12. So we have 1x cubed. 5x squared plus 2x squared is 7x squared. 6x plus 10x is 16x plus 12. So we see that the multiplication is commutative as well. All right, and the last one, f of x divided by g of x over g of x over f of x. So it's x squared plus 5x plus 6 over x plus 2, x plus 2 over x squared plus 5x plus 6. Okay, so first thing to check is what x's can I not use? I cannot use, so x cannot equal -2. We look at that in the original equation. But the first thing you want to do whenever you have fractions, if you have a polynomial, factor it out if possible. So we have x plus 2 on the bottom. So here we have x and x. The second sign is positive, so they're both the same. They're both positive, the first sign. What times what is 6? When I add them, I get 5, 2, and 3. Which x plus 2's cancel. So my graph will look like x plus 3. With a hole where x equals -2. Remember, we can't have a -2 because we make a 0 on the bottom. But since we canceled it, x equals -2 is called a removable discontinuity. And that's why it's a hole. The removable discontinuity, so at whatever the value at -2 is going to be, so -2, 1, my graph will have a hole in it. Let's take this one. So same thing. We have x plus 2 on top. The bottom factors out to x plus 2, x plus 3. So now we know that x cannot equal -2 and x cannot equal negative, because I set both of these equal to 0. You cannot have 0 on the bottom. So those are my restrictions. But since those cancel, I get 1 over x plus 3. Now I have something called an asymptote. I cannot use -3 anywhere. It's going to be a vertical line that I can't use. This graph, as we looked at earlier about moving things around, this one shifts to the left. And we have so our graph will look something like this. We just cannot use that. Now, where it's -2, 1 over 1. So at 1, I have a hole. So at -2, 1, I have a hole. from my graph. So that's what the algebra of polynomials. You can also, in polynomials, you can have coefficients. So if I have 3f of x plus 2g of x. So that's 3 times x squared plus 5x plus 6 plus 2 x plus 2. Distribute 3x squared plus 15x, positive, positive. 6 times 3 is 18. Positive 2x, positive 4. Once you get rid of the parentheses, combine like terms. 3x squared. 15 plus 2 is 17x. 18 plus 4 is 22. So there's what we can do. Pretty straightforward. Now, the last thing in this section is pretty important. It's called the difference quotient. The reason this one is important is because this is where calculus begins. The difference quotient pretty much looks like this. That's the difference quotient. They're differences because they're minuses, that's a difference, and a quotient means fraction. But here's the thing about it. This equation is only good if you have 2 points, x1, y1, x2, y2. And that's good for finding the slope of a straight line. Where you have 2 distinct points. But as we've seen, what if we have a curve where x1 is here, x2 is here, does that find me the slope of the curve? The slope of the line secant to the curve. Or we say the secant line. By secant, we mean a line that crosses a curve at 2 points. That's what a secant line is. It starts here and ends here. It's a line that goes between them. We want to know what is the slope of that line right there, where it touches the point, the curve at 1 point. This is the secant line. So we want to know what the slope is of the curve at that point. We need to have the slope of the tangent line. To find the slope of a curve at any one point, we need the slope of the line tangent to the curve at that point. We only want one x value. We only want one x value. So how do we do that? So we know we have that point and we have that point. Yeah, let's put this into functions. So this is the function at x1. So the y value at when x is 1. And this one is f of x2. So let's build this formula up. We started with the slope, x1, y1, x2, y2. We then converted it to functions. So you see the problem with this, we have x1 and x2. We can only have one variable in there, one x. So let's see this. What do we call the distance between x1 and x2? We call that h. All right, so x1 plus h equals x2. So if this was at 3 and h was 2, then this would be 5. So we have this. We can write x2 as x1 plus h, because h is any distance between there. So x2 is x1 plus h minus f of x1, x1 plus h minus x1. So you notice, since we have only one x value in there, we only have the x1 now, we don't have to put the subscript anymore. We have whatever x value we pick. So we have x plus h minus f of x. Let's fix the bottom. x1 minus x1, they cancel, so we just have h. And that is the difference quotient. Now, as h goes to 0, as h goes to 0, this distance becomes closer and closer, and smaller, smaller. Eventually, when h is 0, x2 and x1 are the same point. And then that's what we have there. That's the slope we're looking for. Because what we're looking here is as x2 gets closer to x1, the slope changes. So that's what we're looking at. This is the formula we'll be looking at. All right, let's look at some examples. The difference quotient is f of x plus h minus f of x over h. Let's try 3x plus 2. Find the difference quotient. So to find the difference quotient, first step, find f of x plus h. Basically, it's put a plus h after each x in your equation. So for the f of x plus h, anywhere I see an x, I put a plus h behind it. Make sure you put in parentheses. Put them in parentheses. Second step, plug f of x and f of x plus h into the formula. F of x plus h minus f of x over h. So f of x plus h is 3x plus h plus 2 minus f of x is 3x plus 2 over h. Simplify. So inside here, first of all, I don't need the outer ones because there's nothing in front. So I have 3x plus 3h plus 2. That's this. Now this one, I got to change the signs of everybody inside there. So it's minus 3x minus 2. Note, everything after the minus sign must cancel. In other words, everything, all these numbers here, 3x plus 2, when you do this, these have to cancel, they have to disappear. If not, you did something wrong. So We have negative 3x and a positive 3x, a negative 2 and a positive 2. H's cancel, and our slope is 3. Well, we know that already because our original equation is mx plus b. The slope we knew was supposed to be 3. That's just a way of testing it. Okay, so let's look at this equation. Same procedures. We first have to find f of x plus h. So anywhere see an x, I put x plus h in parentheses. So anywhere see an x, I put an x plus h. I plug it in the formula. F of x plus h minus f of x over h. So f of x plus h is x plus h squared, 3x plus h plus 2. That's the first part. Minus, that's this part. Whatever's after the minus goes in parentheses. Because, remember what we said earlier, anything after this minus sign, all this stuff eventually has to cancel. So now we got to simplify. This first part, I'm going to put it up here. So this first part is x plus h squared, which is x plus h times x plus h. X times x is x squared. Xh plus xh plus h squared, which makes it x squared plus 2xh plus h squared. This first part is x squared plus 2xh plus h squared. That's this part here only. Then I got to do these. 3 times x is 3x. 3 times h is 3h. That's that one. Plus 2. Distribute that negative sign, so it becomes negative x squared. Basically, it just changes all the signs inside there. There's negative 3x, makes it negative 2. Negative x squared cancel. Negative 3x and the 3x cancel. Negative 2 and the 2 cancel. So this is what I have left. Two xh plus h squared plus 3h. Factor out an h. For each of the top has at least one h. So we take out one h. Just 2x plus h plus 3. Those cancel. So it leaves us as 2x plus 3 plus h. So this is the formula. Now, as h goes to 0, we get 2x plus 3. For whatever x you give me, that's going to be the slope. All right, let's look now a fraction problem. One over 3x plus 2. The same steps. We have to find x plus h. So anywhere we see an x, I put an x plus h. Right, so let's now plug everything in there. We have f of x plus h minus f of x over h. That's the h. So f of x plus h is this one. So it's 3x plus h plus 2 under 1 minus f of x is 3x plus 2. So what we have to do first, let's make this look nicer. So this is going to be 3x plus 3h plus 2 3x plus 2. These are the numbers. I have to stay together. Now, the rule of adding, subtracting fractions is in order to add, subtract them, you have to have a common denominator. So since this one has 3x plus 2, this one doesn't. This one needs a 3x plus 2 on top and bottom. This one has a 3x, 3h plus 2. This one needs a 3x plus 3h plus 2, top and bottom. All right, so our denominator, we have a common denominator now. 3x plus 2, 3x, 3h plus 2. That's the bottom number. On top, we have 3x plus 2 times 1 minus all that times 1, which is 3x, 3h plus 2. Okay, we're getting closer. Let's go ahead and fix the top. We don't need the parentheses there, so we have 3x plus 2. This negative changes everybody's sign inside there. 3x minus 3h minus 2. Three x cancels, the 2's cancel, so all we have left is negative 3h on top. Okay, leave the bottom, this one alone. So now we have a fraction over a fraction. The rule for that is if you have a fraction over a fraction, you have a over b over c over d. Leave the first top fraction alone and flip the bottom. So that's the rule there. Leave the top alone, negative 3h, 3x plus 2, 3x plus 3h plus 2, times flip the bottom. H's cancel. Okay, so here's one answer with the h in there. As h goes to 0, this h disappears. That h goes to 0. So we have negative 3, 3x plus 2, 3x plus 2, which becomes negative 3, 3x plus 2 squared. That's your slope at any x you give me. Yes, when you have fractions, it gets big really quick, and then it simplifies down really fast also. But you have to remember, you have to get a common denominator, multiply it, so this one goes to there, this one goes to there. Simplify the top, flip the bottom, and h goes to 0. Okay, another example that we have is a radical. So the first thing we got to do is find x plus h, which is x plus h plus 1. That's the first one, minus x plus 1 over h. Now, if h goes to 0, that becomes 0. You can't have a 0 on the bottom. Then you have radical x plus 1 minus, that becomes 0 over 0. We can't have that. So the problem is we have to get rid of the radicals. The way we do that is multiply by the conjugate of the numerator. The conjugate is if we have a plus b, the conjugate is a minus b. Just change the sign between there. So we have radical x plus h plus 1 minus radical x plus 1. So we have to multiply by 1. So we have to multiply the conjugate, which is radical x plus h plus 1. Change that to a plus. So you change that to a plus. And you multiply it over itself. Because all we're doing here is changing the way the equation is going to look, because this isn't the same as number 1. It's the same number over same number equals 1. So the top we have to multiply, because this is multiplied. Radical times a radical is just what's inside there. This radical times that radical, positive times positive is positive x plus h plus 1 times x plus 1. Now this one, minus x plus h plus 1 times x plus 1. Negative times positive is negative. Radical x plus 1, radical x plus 1, since they're the same thing, I have x plus 1. Now on the bottom, the radical times is the same thing, it's just squared. The exponents, the squares cancel. Right? If we had x plus 1 times radical x plus 1, that equals radical x plus 1 squared. The square root and the square cancel, giving us x plus 1. So this and this cancel out. They're the same numbers, opposite signs. X plus h plus 1 minus x plus 1. I don't need the parenthesis on the top one, so it's x plus h plus 1. This one distributes, so it's x minus 1 all over my denominator. Let the x's cancel, the 1's cancel, so we just have h on top. The h's cancel, which leaves us with 1 on top. X plus h plus 1. And that's one of our solutions with h in there. Or as h goes to 0, our slope becomes 1. That goes away, so it's x plus 1 plus radical x plus 1 equals 1 over 2 x plus 1. Okay, so that's how you use the difference quotient to find the slope of a curve at any point. So look, what's the point of this? Let's look at this one. So let's say I'm using this last example. Find the equation of the line tangent to the curve at 3, 2. We plug in 3. 3 plus 1 is 4. Square root of 4 is 2. So this is an example. Find the equation of the line tangent to the curve at that point. So part 1, find the slope. Since it's a radical one and it's a curve, we do all this stuff. So eventually after all that stuff, we get m equals 1 over 2x plus 1. So yeah, 1. So all this came from the previous page. Plug in the x value. So the slope, the x value is 3, is 1 over 2, 3 plus 1. So the slope is 1/4 at the point 3, 2. Part 2, find the equation of the line tangent to the curve at 3, 2. This is the equation of the line. So we want this. We have x, we have y, and we have m. So y is 2, 1/4 is the m, 3 is the x, so we have 2, 3 over 4 plus b. Find the LCD. In this case, the only denominator is 4. Multiply each term by the LCD. So we have 4 times 2, 4 times 3/4, 4 times b. Reduce. So we have 4 times 2. The 4's cancel. Multiply to get rid of the parentheses. So I subtract 3. 5 equals 4b. B equals 5 over 4. And m equals 1 over 4. So my equation that's the equation of the line tangent to f of x at 3, 2. All right, so that does it for this part of the class. That does, yeah, we finished sections 1 and section 2. We're going to skip section 3 because we'll do that at the beginning of chapter 5. And then we have sections 4 and 5, which are symmetry and transformations, which go together. And we'll finish that up on Wednesday. All right, have a great day. I'll see you guys in class on Wednesday. Bye. Enjoy the day.